This is my note on electrochemistry. So as we go through, essentially what we're looking at when we're looking at electrochemistry is any kind of a chemical reaction that involves the transfer of electrons. So a couple of terms and definitions that we need to know. The first one is oxidation. And although in some cases oxidation generally refers to an attachment of oxygen to something, in electrochemistry it has a different connotation. It's actually the process where a chemical species loses electrons. As it turns out, in any kind of a reaction where oxygen is attached, that also has to happen, and so that's why it's quite often used, especially in organic chemistry, with the term of adding an oxygen to something, hence the word oxidation. That's probably where it comes from. The other term is reduction, and this is a process where a chemical species gains electrons. Wherever you have a situation where you have oxidation taking place, something has to cause that. You can't have something giving off electrons to just any old place. The electrons have to go somewhere. And so they go to the oxidizing agent. Okay. In the process, the oxidizing agent undergoes reduction. Similarly, if something is reduced, something else has to cause it to be reduced, and that's the reducing agent. And that species is then oxidized. So the two always go hand in hand, because for electrons to be given off by something, something else has to take those electrons in order for that sort of process to happen. How do we keep them straight? Because this is always confusing. Which one is which? I've always used the acronym LEO, the lion goes grr. And LEO, loss of electrons, is oxidation, and goes grr, gain of electrons is reduction. Now this primarily happens with single displacement reactions. So these are single displacement reactions are redox reactions. Because in order for something that's an ion to become a metal, there has to be a gain or loss of electrons. Similarly, something that's a metal or element has to go to an ion, it has to gain or lose electrons. And so that electron transfer then necessarily makes it a redox reaction. Now, up till this point, we've used the activity series of metals to tell us which metals are more reactive, which ones cause the others to be reduced. The most reactive metals will spontaneously undergo oxidation, causing the less reactive metal ion to be reduced to the metal. In these types of reactions, the oxidation numbers of these elements will have to change. And so we need to be able to assign these oxidation numbers to the different elements that are involved in a chemical reaction. And this is where we kind of learn to understand what the oxidation number actually means in the periodic table. Up till now, we've always considered it to be the charge. But where these charges come from, we never really talked about that. And so what we need to understand is that oxidation numbers really are the numbers that are assigned to the atoms according to the charge that an atom would have if the electrons were given to the more electronegative atom. So when you put a compound together of several elements, the most electronegative element gets the negative charge. And if all the electrons that are given off by the other ones went to that most electronegative atom, then the charges that result, those are the oxidation numbers then. So in order to assign oxidation numbers, these are the rules that we use. First of all, the oxidation number of an atom in a free element is always 0. Secondly, the sum of the individual oxidation numbers must equal the overall charge of the molecule. Hydrogen and the alkali metals, so first column elements, they always have an oxidation number of 1+. The alkaline earth metals have an oxidation number of 2+. And both of these apply when they are in compounds. Fluorine is the most electronegative element and always has an oxidation number of 1-. Oxygen is the second most electronegative element and always has an oxidation number of 2-, except when it's bonded to fluorine, which is always more electronegative. Then it becomes a positive oxidation number. The remaining halogens have an oxidation number of 1-, except when bonded to oxygen or a more electronegative halogen. Unless rules 1 to 6 require otherwise, the atoms from groups 5 and 6 are assigned oxidation numbers of -3 and -2 respectively. Now, you can only have a redox reaction if there is a change in the oxidation number of some of the atoms from reactant side to product side. If there's no change in oxidation numbers from one side to the other, then there's no redox reaction. So let's do this as an example. The reaction with lead 2 sulfate with magnesium. That gives us magnesium sulfate and lead. And so assigning oxidation numbers. So following the rules, oxygen is always going to be the 2- here. There's 4 of them, so that's 8-. We don't neglect what we learned before. We know that the sulfate ion overall has a 2- charge, and so in this case the lead has to be lead 2+, and that kind of comes from the name, right? Lead 2 sulfate, right? So lead has a 2+ charge, so that means that the sulfur then has to have a 6+ charge in order for that to work out. Magnesium here is a metal, so it's going to have a 0 oxidation number. The magnesium sulfate is going to be very similar to the lead 2 sulfate, 2+, 2- for the oxygen, so therefore the sulfur is going to be 6+. You'll notice that the sulfur and the oxygen are the same from one side to the other. Lead metal, because it's an element, has an oxidation number of 0. And so we can see that the things that change oxidation numbers from one side to the other, lead goes from 2+ to 0, and magnesium goes from 0 to 2+. So in order for lead to go from 2+ to 0, it has to pick up 2 electrons. Where does it get them from? Well, the magnesium goes to the magnesium 2+ ion, gives up 2 electrons. Those are the ones that the lead picks up. All right, so just to summarize, the lead has a 2+ charge going to 0, so that's a gain of electrons, which is reduction. So the lead is reduced from 2+ ion to lead metal. And then magnesium going from 0 to 2+, that's a loss of electrons, which is oxidation, and so it is oxidized to the magnesium 2+ ion. Now, this process is what we call the half reaction. Okay. While one species is oxidized, the other is reduced, because you can't have the two processes happening independently. They happen together, right? Now, if we, on a piece of paper, separate those two processes, we get what we call the half reactions. So, lead, going from 2+, picking up 2 electrons, becomes lead metal. Magnesium, metal, giving up the 2 electrons gives you the magnesium 2+, 2 electrons are given off as well. Okay, so these are the half reactions then. Notice that with half reactions, the electron transfer is included. Okay, this is useful later on when we learn to balance these. And this is important. The total number of electrons gained is always the same as the total number of electrons lost. All right, so let's just review again. Oxidizing agent is the element that is reduced. The reducing agent is the element that's oxidized. All right, this section will have your homework on these pages. Try those, see how well you do.